All right, boys and girls, welcome back to the drive-through for a special Positive Wednesday addendum version brought to you by the deli. Hungry? Stop by the deli. Get yourself breakfast or brunch for lunch, which is what we had today. It was absolutely magnificent. If you're wondering, I made a bacon and peanut butter sandwich on pancakes with syrup. It was so good. So good. Okay. So we're going to do a proof and we're going to do a triangle inequality. Two things that that kind of make people stumble in this section. Specifically, this problem number 14. It's asking you a very specific thing. We're trying to prove that AB is parallel to CD. Okay, and in order to do that, I've got to use one of our new theorems, right? Here's the thing, though. What you might want to do is rewrite the diagram without including the other two lines that are parallel. Because inherently, what always happens is people will prove those two lines, or those two angles congruent to each other. And which sides does that prove to be parallel? The top and the bottom. You see that? And that's not what they're asking us. Another thing that's tricky about this is that students have never really had to do this so far this year, but these triangles are flipped. So you've got to make sure you get your congruent statement right. So let me plan this one out. Look for N's and Z's. That's a little trick. So you see your N? If the angles inside the N are parallel, then the lines, are congruent, then the lines are parallel. So our new goal is to prove that this angle is congruent to this angle. Well, it's not that hard at all. We are given that AB is congruent to CD, so I'll mark it. AB congruent to CD, and we are given that BC is congruent to AD, okay? So we are a step away from proving our triangle's congruent. So what comes next? BD. Now if you're a baller, you might want to call it DB because it's flipped in the other triangle. No, you wouldn't be wrong if you didn't do it, but here's where you would be wrong. Here, this step is wrong. I'll fix it. Very common mistake. Triangle BAD is congruent to triangle BCD. Sorry, to triangle BCD. You just got it wrong. And now your CPCTC is going to be messed up. Do you see what I did wrong? In the one on the left, I went down the one tick mark and then the two tick marks to complete it. On the one on the right, I went down the two tick marks and then the one tick mark. They don't match up. Do you see that? So what should I write here? Triangle BAD is congruent to what? DCB, right? Is that what you said? Would you put ABD, then you better have put in CDB. Is that what you put? Awesome. And why did I just get this wrong? Oh, no, I didn't. I didn't see my reflexive step. Okay, there we go. Side, side, side. So now you got to make sure you pull out the correct angles. So which ones am I going to pull out? This one and this one. So what are they? Angle ABD is congruent to what? CDB. ADB, CBD. If not, then that's wrong. Oh yeah, CDB. Good job. And that is CPCTC. And so finally, I've got AB is parallel to DC. And my reasoning is if alternate interior angles are congruent, then the lines are parallel. Does that help? Okay. Remember, understanding proofs and doing proofs for yourself are totally different things, and I think some of you learned that the hard way yesterday. Okay, hopefully you can see this from your desks. If not, this says 3x minus 18, and this says 30. Okay, this is number 17. All right, the book did a really good job of not the book. The video, my video, did a really good job of teaching you half of this. So 3x minus 18 and 30. What's the relationship between those two? Is greater than. But there's another part of this. I want you to imagine that this angle is 0 degrees. I know it can't be 0 degrees, but it can be that, right? So now just imagine that it's 0. If it was 0, what would this one be? This would be like very close, that's a good way to put it, very close to 150. I mean, it can be infinitely close, right? So not only does 3x minus 18 have to be greater than 30, but what else is true? 3x minus 18 has to be less than 150. It's got two requirements. It couldn't just be like a million, right? So it's got to also have an upper limit. And so you just solve these. Remember when you divide by a negative, what do you do to your fraction or to your inequality? Do you understand why that is? Which one's bigger? Now multiply them both by anything negative. Same thing. How about this? Negative 1. Now which one's bigger? And that's why you flip the sign. Do you understand that? Never forget that again, because we make it too big of a deal and kids forget about it. It should just kind of make sense to you. Okay, we won't have to be doing any flipping in this one. You get 3x is greater than 48. So x is greater than 16. 3x is less than 168. So x is less than 56. So then you would write that as x is greater than 16 and less than 56. Sound good? Boom!